to talk to you about intelligent query processing. And I'm Kathi Kellenberger, and I'm the editor of Simple Talk at Redgate and also a DevOps advocate. However, my role is changing. In approximately 1 month. I'm moving to the customer success team. So I will not be the editor of Simple Talk after that. And I am also a volunteer at an organization in St. Louis called LaunchCode, where we train folks who are interested in starting tech careers, but they've never had maybe the opportunity or the education or experience, or something's holding them back, and we get them into tech careers. So I'm very proud of that. The most important thing to know about me is that I'm a lifelong learner and teacher. So you might have seen this chart before if you've seen any other sessions about intelligent query processing. But what's really important about me, to me, not about me, to me, about this topic is that, before joining Redgate, I was a consultant for several years, and I often found myself in different query tuning or performance tuning engagements, and I started seeing the same kind of patterns over and over that caused issues. And some of them were pretty low-hanging fruit, pretty easy to solve. And but over time, I guess a lot of folks complained, or there were a lot of a lot of these same practices over and over in customers' code. And so eventually Microsoft started looking at some of these issues, and some of them are how SQL Server works. Some of them are certain query patterns that are used, and started adding features into SQL Server that takes care of these issues without changing code. And there's one exception at this point about changing code, but it's some pretty cool changes that make SQL faster just by upgrading. So most of these are available on any edition of SQL Server, except for a handful. There's this thing called adaptive joins. That is Enterprise Edition only, and memory grant feedback is Enterprise Edition only, and batch mode on row store. So don't worry if these terms don't make a lot of sense right now. I'm going to go through and explain each one. So the first one I want to talk about is called batch mode adaptive joins. I feel like the names of these are kind of descriptive, but in some cases, maybe not so much. Like, what in the world does this mean? So you may have seen query plans where if you have a small number of rows, and that's the first time that query runs, or that stored procedure runs, and that it uses a nested loop, because there's just a small number of rows, and that's the plan that makes sense for that particular query. However, if a large number of rows, if that data is skewed, then a hash join would be better. Maybe with the nested loop, a seek would be better. Maybe with the hash join, it's going to be a scan. So the problem is that plan gets stored in cache. And this is that thing we talk about all the time called parameter sniffing, and which I ran into a lot when I was doing consulting, and I suppose probably a lot of you have as well. If your data is skewed, you're going to have problems, and there's a ton of workarounds. So starting with 2017, Microsoft introduced this feature called batch mode adaptive join, where this plan switches based on the row count. Unfortunately, right now, it only works in, it only works in 2017. I'm sorry, only works if you have a column store index starting with 2017. And it requires Enterprise Edition only. I'm hoping that at some time they expand that. I don't believe they've expanded it in 2022, anything that they've announced yet, unless I'm missing something. So let's go ahead and take a look at how that works. So I am going to, I feel like there's a little bit of feedback coming back. I don't know if there's a mic on somewhere. So I'm using Wide World Importers, DW has some column store indexes. However, I had to skew the data purposely just to get this to work. So I deleted a bunch of rows to get this to work. And I'm going to use a stored procedure. You'll see me doing that in most of the demos. And that's to make sure that I don't accidentally add a space or an extra white space and make SQL think it's a different query. So I'm going to do that. So everything will always be parameterized and it will be the same query each time. So what I'm going to do is set this back to 2016 compatibility level to see what it looks like before we before I turn the feature on. My brain and mouth are not connecting today. All right, so, and I've got that on. So with this particular, I can get that to go away, good. With this particular parameter, I'm getting back 206 rows, and the best plan for this is a clustered index scan with a hash match, okay? Because we've got, you know, a large number of rows coming through. That is the best plan for this. I cleared the cache out. I know that, or at least we think it is. I mean, it's possible that there's more plans that SQL didn't have a chance to look at, you know, to fully vet, but that's a pretty good plan for that number. So here is another value. In this case, I only have 5 rows coming back. I cleared the cache. So in this case, I get a very different plan. I get a clustered index seek, and I get a nested loop because there's only just a handful of rows going through this plan. Okay, so I freed the cache before I ran this one. So what happens if I run this one? And we know this one with 360 that I ran before prefers the hash match. But what happens when I run it? Now I've got that nested loop. I'm stuck at that nested loop, and that can be a problem. This is only, you know, not that many rows, 206 rows, but if it was, you know, 10,000 rows or 1,000,000 rows, and it was, your data was skewed that much, this could be a big problem all of a sudden to have this large amount of data going through a nested loop. So what I'm going to do to solve this problem is set the compatibility level to 150, which is, I think that's 2019. Yeah, 2019. I'm wondering if I got my, usually I set it to the level you need, but I've got it to 7 to that. I'm going to free the cache just in case. Ooh. And I'm going to go ahead and run this first one. And this is the one with just 5 rows. And when I look at the execution plan, I see something, I'm really hearing a lot of talking in the background. You can check to make sure the mic's off, everyone. I'm seeing something I have not really seen before, okay, called an adaptive join. And the other really interesting thing about this plan is I see 2 pathways for the data coming through from that table. It can either be a clustered index scan or a clustered index seek. So notice that this says 0 rows here, and this says 5 rows. So this is the path it actually took. And if I look at this, and okay, if we look at this, we can see that we now have this estimated join type and actual join type. So this is new. And the actual join type that was used is a nested loop. If we run this one, let's see what happens. Again, I've got this unusual plan that's, new. And this time I see 0 rows went through the seek. And it's only saying 2 of 7, which it's actually 672, but maybe for each time it went through. So this time it did go through the clustered index scan instead of the seek. And when I mouse over the adapted join, get that to stay. Again, the estimated join is nested loop, since that was the first one that went through, but the actual join was a hash match. So if I have this particular situation, which is I'm running Enterprise Edition, I'm running at least 2017, and I have a column store involved, I don't have to worry about this particular issue. So there's a lot of caveats to it, but I'm hoping as every version of SQL Server, Microsoft adds more and more features to this, I'm hoping that this expands so there's not so many requirements. So are there any questions about this?
What is a seek?
What is a seek? Okay.
Oh, seek. I'm sorry. Yeah.
An index seek?
Yeah.
Okay, so an index seek, we could have a whole hour just on indexing. An index seek means that the index has a particular key, let's say product ID, and that's the key to that index, the first item of that index. So because of that, SQL Server is able to go very quickly and find the row. Okay, it's kind of like if you had an index in the back of the book where it tells you exactly what page to go to. Okay, so it's very quick. You just go straight to that row. The difference is an index scan where SQL Server has to read the entire index. So if I have a million rows in a table and I have to scan that, that's going to take a while. That's like reading the whole book. But if I have an index seek, because that term is in the index, I can just pop right to the page I need. So it's kind of the difference. It's the difference between reading a whole book and popping to the right page.
Okay, I understand. But it seems like that's the whole reason for having an index, isn't it? So that you can avoid selecting or reading all those records, all those rows. And
Right.
the point of having an index is so that you can eliminate most of the data and go right to the area you need to look at.
Right. In some cases, it is faster to do that. In some cases, it is not.
Okay.
Yeah, so SQL Server will look and see which one makes sense.
So a seek doesn't actually read the data, but it finds the area where the data is going to be found.
If it's searching a non-clustered index, it'll find that particular, I don't know how to really say it, that particular item. So let's say you have an index that's got product ID, but it also has product name. The top of the index is like it's like a binary tree. It's not exactly a binary tree. It's called a balanced tree.
Right.
At the top, it's going to be sorted, product ID. I'm at that leaf level is what you call it. And in that leaf level, I'm also going to have, let's say I have product name as a included column. Product name is going to be found there.
Okay.
So so
thank you.
maybe we could have a whole session sometime on indexing if your group would find it helpful.
I would love it.
Yeah. Okay. That would be great. Any other questions?
Hi, Kathy. When you were looking at the adaptive join operator in the execution plan, underneath it you had like the two different types of join, the hash join and the what was it, the nested loops, I guess.
Mm-hmm.
And on one it said 0 out of 5 or 0 out of 7. Was it? That one said 2 out of 7, was it? But beneath that in the seek, it had a different figure. Was it 4 out of 5? Well, I was thinking about the other example, but
yeah,
I didn't know what the 4 and the 7
I think
referred to.
what it's happening here is that it's sometimes, how do I say it? I know it better with the nested loop. Let me switch to that one. Is that the nested loop one? Yeah.
Yeah,
so it doesn't always go, especially with the nested loop, it doesn't always go. Yeah, that's 5 of 4, which seems odd.
and the fact that
so there's multiple executions that go through. Yeah, I'm not sure, these numbers are kind of goofy. I agree with that. But a lot of times you'll see something that it'll say 1, but it's executed, 1,000 times. And you can see number of rows per execution. You can see more by mousing over.
Oh, yeah, okay, you can get the detail there,
Yeah.
sure.
But yeah, the numbers look a little strange through here because you do end up with 5 rows. However, this says, 5 of 4. 5 do go through. The other one, let's see what it says.
Isn't this because of a statistics?
Statistics should be up to date, but yeah, it could be a little bit off. So this one's 0 of 4. This 2 of 7 seems strange, but let's look and see what that does. Actual number of rows for all executions, number of rows read, 672. So it did read 672 rows. So it evidently is
could be based
sending
on the statistics, on the estimated statistic, or the statistics it knows at the time, I suppose.
Yeah, I know the statistics are up to date. I didn't look at them, but I know that whenever I made the modification to the table, I updated the statistics. So let me find out a little bit more about why this number doesn't say exactly what we expect. If I mouse over here, I can see why am I thought I saw 260 someplace. Actual number of rows for all execution. Oh, 672 were the number of rows read. So I would think in this case, they would all go at once because it's a hash match. But let me see, I might be able to ask Grant Fritchie, whom I work with, to see if he can explain this a little more, because he's written several books on
Execution
query
plans.
plans.
Yeah.
Because it does look a little goofy. So I'm writing this down.
Thanks.
Let's see, that's adaptive join. Okay, I'm going to move on to the next one, which is called Interleaved Execution. Again, it's the name to me doesn't really tell you what it's about, but imagine that you have a table valued function. Maybe someone said, oh, change that user defined function or do this as a table valued function. Well, there's a couple different kinds of table valued function. One's called inline. If you have inline under the covers, SQL Server just changes it to a join. But if you have multi-statement, that can run into some problems, because that multi-statement table valued function runs once for every outer row, or once for every row that's returned. And in multi-statement meaning, I might have ifs in there, I might have loops, I might be creating a table variable and populating it. I might be doing all kinds of things in that function. But then it returns tabular data that I can then join to other tables. SQL Server in the past always estimated that these would have 100 rows. So that can be a really big issue if they in fact have 1,000,000 rows. If they just have a couple hundred, it's not going to be a big deal. But if they have millions of rows, then they can cause a problem. That estimate can cause a problem. And, you know, the wrong plan will be chosen. So what Microsoft did starting in 2017 is they go ahead and create the table first, and then have it in place and actually know the count. So then the plan can be adjusted. And I probably misspoke. I don't know that it's run multiple times. It's another one of those, it depends. One of the issues with this one is that the parameters you're passing in have to be static. By static, I mean a hard-coded value or a variable that has one value. If you are sending in multiple, you know, like sending in a column, this doesn't come into play. So let's take a look at that. Because theoretically, if I'm just sending in, for example, 2 dates or a product ID or something like that, it only needs to run once. But if I'm sending in columns, then yeah, then that will have to run multiple times. It'll have a certain match for each row. So we're going to use AdventureWorks on this one, and I will set the compatibility level to 130. So I have a query here, or actually a function, a multi-line table valued function where I pass in a start date and end date. In this case, I am just going to be passing in some hard-coded dates, and it returns the product and the total sold. So here's my, so what I'm doing inside here is I'm adjusting the end date and then inserting it into this table to be returned. Now, if I hadn't done this, I could have just made this an inline table valued function, which would have been fine. So let me go ahead and create this. And I'm going to call it with in a query, and I'm passing in hard-coded values. And if I was going to pass in columns instead, I would have to do a cross join. But in this case, I'm doing an inner join. So this is really the situation where this comes into play. Double check, did I run? Make sure I ran that. All right, so I'm going to run this again just to make sure I had the right compatibility level. So I get back 238 rows. And when I look at the execution plan, I see that in this case, there were 238 rows, but the estimate was just 100 rows. And it used a nested loop for that. The other thing is that the only table that it mentions here is the product table. But if you paid attention to the definition of that user-defined function, you would have seen that there was, the detailed table, the order header table. There were multiple tables involved. So SQL Server doesn't report that back to you. If I look at statistics.io, you'll see again, it only sees the product table. However, it actually is touching those other tables. So this execution plan is really hiding things from you. So if I set the compatibility level and run it again, and actually I should make that, I'm going to leave it. I forgot that I had that thing to adjust the date, but that's fine. And now I get 238 rows back. But in this case, it shows that I do have 238 rows back, and it shows a different plan, the hash match. So if for some reason, and 238 is not really a lot of rows, but let's say sometimes it was going to be 1,000,000 rows, and sometimes it was going to be 100 rows, something like that. This could really cause a problem because it would never really know what to do. Here's one other issue with this is that, and I picked, let's see, I've got a month here instead of a year. If I change these values, it's going to remember. Did it not remember? I thought it was going to remember. It did before. This case, it did not remember. Oh, yeah, it did not remember, or it did remember the number of values. In the past, I've seen it stick with that same value here. So I'm not sure if the cache just got cleared out, which might be possible. Because earlier today, I got the same plan. Let's see, let me run this one again real quick. I got the same plan and the same number of rows. Let's see what happens here. Oh, it's working the way I would like it to work, but not how it worked earlier today. So it looks like it's not saved. Oh, wait a minute. Let me back up because I'm getting it mixed up with something else. It does not save the count in cache. I am seeing the correct thing. There's so many of these and they start getting jumbled in my brain. In this case, since SQL Server has to go out and run that function with the hard-coded values, it always reruns it. So is the count cached in the plan? No. So that is the answer there. So apologize for getting confused on this. Any questions at this point? Okay, and I am going really slow here, it seems like. I'm not sure how much time I have. Okay, I'm going to go on to the next one. And the next one is table variable deferred compilation. So this is the one where it does store it in cache, I'm pretty sure. So I'll verify that. So this is a situation where, let's say you have a stored procedure and you've decided to use table variables instead of temp tables for intermediate results. And in the past, SQL Server assumed a count of 1. Starting with 2019, the plan adjusts based on the actual row count. However, I believe this one is cached. I think I've got it right this time. And this was introduced in 2019. So let's take a look at that one. In this one, I'm using AdventureWorks again, and I have a stored procedure where I create a table variable, insert some values into it, and then use that to join on other tables to get results. Now, this is a really simple example. There's no reason to actually do it in this little contrived example, but I just wanted something that I can demonstrate. So I'm going to set the compatibility level to 140. And let's take a look at the plan. So the first one is just populating that table. I don't care about that. What I am concerned about is this right here, where it says that it's 121,000 rows of 1. So the cardinality estimate has always been 1 on this. So we see a lot of problems here. We see a nested loop, and there's way too many rows to come through a nested loop. And also, sort has spilled to tempdb. So this is definitely a bad plan for that number of rows. However, that's what you would always get. If I switch it to 2019 compatibility level, again, I don't care about that first one. Now we get a different plan. We get a table scan. It shows that it's looking for 121,000 rows. Now it's got the hash match, which is appropriate for this. The one issue here, though, is you still do not get any statistics. So even though we've got the cardinality, there's no statistics on these table variables. That can be bad. Okay, here's the one that I was thinking of earlier. So here's one where I'm just going to send in a couple of dates. Otherwise, it's the same, and I've added the dates to the where clause. Let's execute that. And ignore this part because I was just trying to find the min and max dates in the database. So I'm going to run this one, which is only 1504. So that one's coming through. And let's see, where is my, oh, this is the wrong one. It's by date. Guess it's the right one. I'm seeing a table insert there. Just looks odd. That's my insert. I'm not seeing what I want to see here. Because I'm seeing that table insert, I'm not seeing the other one. double check that real quick. Ah, I see the problem. I deleted something that I should not have deleted, I guess. Okay, let me try that again. I thought that that was just something I had done to come up with the min and max, but no, it was part of the demo. Okay. Now I'm seeing what I want. Okay, so in this case, the first time we ran this, I see that it saw that there was 1509 rows, which is right. And the second time, with a smaller number of rows, it's also saying 1509. So that 1509 is stuck in that plan. Let's see, oh, 31, and I'm sorry. Let's change that to 12. That's what I get for changing up my demos the morning of the session. Okay, so you can see here that 1509 is stuck there. I have a lot more rows going through, and I'm stuck with that other plan. So any questions about that one?
You said it was cached, right? So
This one, the count is cached. Yes. So
that's just for the life of the table variable, I guess. So.
It's for, no, longer than the life of the table variable. It's stored in the cache, in the procedure cache. So whenever SQL Server runs this again, it's going to look in the cache. Is there a plan for this already? I'm going to use that one. So that number is stored in that.
What happens if we?
Yeah, so if you rerun it when you populate it with a different number.
Well, that's what I did. Let's do this one. Let's do 4. Yeah, so that's what I was doing here, populating it with different values. So see, it's always stuck at 1509 until that comes out of the cache. Now it might come out of the cache because there's a lot in there, and this is not used much, and older plans get knocked out, or with a restart, or with whatever reason. But as long as that plan is in the cache, it's going to say 1509. So this is.
You might still need the recompile option then.
Yeah, but then, most people are using table variables because they don't want to use recompile. So, but if you always have, let's say you have a table variable that always gets populated with thousands of rows, this is great, because otherwise it's going to come through as 1. It's always going to say 1 before SQL Server 2019. So this is better than always saying 1. This is just a caveat. If your data is really skewed, you could run into some issues.
Cool.
So these are really great features. However, I just want to point out when they don't work as well as we might hope. Okay, Scalar UDF Inlining has to do with UDFs that you might have, for example, in the select list or the order by clause. Okay, and these run over and over and over, regardless of what's in there, for every row in the outer results. This is a big problem for lots of shops because they just don't realize that's what's happening. So what this feature does is, if possible, it will, under the covers, make it like that was just a subquery in the select list or a formula in the select list, whatever it can do. There are a lot of caveats on this one. It doesn't work in all cases. And it was introduced in 2019. So what I'm going to do is turn on this live session data here for this one. And got my session running. So I'm going to create a user-defined function that you pass in a product ID in a year, and it comes up with just a sum. In this case, it's not returning a table, it's just returning a value. I'll set the compatibility level back. I'm going to drop the clean buffers. What I found is since I have upgraded my laptop, I can't get some things to run slow that they used to run slow. Even though I dialed the memory back on this instance, I'm still getting things to run fast. But let's take a look at this though. You can see that I'm touching the sales order header table, the sales order detail table, and the outer query is production product. So I'm calling this with a column and a hard-coded value. The first thing I want to show you, hopefully this worked, and this is what I've had to do at places where I've done consulting, where they've had UDFs, show them that that runs over and over and over and over. You know, it just keeps running once for every outer row. So every time for every outer row, we're touching that sales order header and sales order detail table again and again. If these are very big tables, if the query inside that function requires a lot of resources, they might not realize what's going on. And I have seen this in several organizations. Let's get back to the one where I'm supposed to be, number 4. Okay, so I originally did this to show the difference in time, but there's not really any difference in time in my machine anymore. Oh, but let me go back and run this again because I didn't show you the execution plan. The execution plan looks like this. It looks like a very simple, wonderful plan. It looks like the effort it goes into the product table and just a sort. It doesn't tell you about the other tables it's touching. It doesn't tell you that it's even in here. It doesn't tell you that it's scanning or touching those other tables. Right, so if I run this one, I'm going to go back to this, make sure I'm going to close it and reopen it. So we don't see the old statements. Okay, so with SQL Server 2019, we look at this, the plan is much more complex. I can see the other tables. It's telling me that there were a lot of logical reads for the sales order header table. It's giving me more information for one, and it's also much more efficient because under the covers, it's just turning that call to the UDF into a join, okay? And let's look at the live statements. So you'll see if we look here, we see one call for this call to the stored procedure. One time this runs, and or not the stored procedure, but the UDF. But I don't have This is just the outer query. I don't have those calls over and over and over to that UDF. It's only called once. Ever I do that, let's see. It will work with things like conditional logic. You can have an if in there. It will work. It will not work if there is a loop. So here's a loop. And they also have a query you can run that, or DMV, I guess, that you can run that will tell you whether your UDF is inlineable. So one for year is inlineable. If it's got an if, it is inlineable, but the one with the loop does not. If you are interested in this feature, if you think it can benefit you, take a look at the documentation, because there's a lot of things where, you know, a lot of caveats, things where it won't work. So are there any questions about this one? And I'm wondering, how much time do I have left? Do I only have like 10 minutes left?
15.
15 minutes left? I'm going to have to just go really fast here. How many do I have? I don't have too many left. Okay. Batch mode on row store. This is a feature that's used in column store where the data is broken up into batches. This is for large amounts of data where aggregates are involved, and then the final results are kind of combined together. But in 2019, Microsoft gave this ability for row store as well. This will decrease CPU requirements. That's the main benefit. And it does require Enterprise Edition. So I'm going to just show you, I'm not going to go through the whole demo just to make sure I can get through everything. I think what I'll do is just show this one here, which is a better. This one is it has windowing functions where I found it was very beneficial for windowing functions. And this one's going to take a bit to run. Okay, it took 3 seconds to run. I think with my old laptop, it probably took 10 seconds. And if I look at the execution plan, we see, you know, a complex execution plan. Notice this table spool. When you see that, that is bad news. That means that SQL Server is creating work tables in TimpDB instead of in memory. Okay. And it took about 3 seconds to run. I'm going to drop this so we don't worry about the data being in cache. I'm going to set the compatibility level and run it again. This time it took 2 seconds. A lot of that time was populating this grid. But if I look at the execution plan, I'll see this new operator called window aggregate. That means that now we're taking advantage of memory, not just TimpDB for those work tables. And if I look at the properties, you'll see that it was batch mode. Okay. Even though this particular query doesn't have any column store indexes involved, it's breaking the data down into batches. This is not parallelism. You might think it's the same. This is not spreading it out over multiple cores. What this is doing is actually breaking the data into separate threads. It is different. So any quick questions on that?
Yes, please. Standard edition. I'd
This
like
one
to
is
know.
Enterprise Edition.
Yes, yes, but there is that hack that Etik Ben Gant discovered.
This hack.
Yes.
Yeah, the problem is I've got developer edition, so I have not tried that on standard edition. So the hack he's talking about is that if you take, if you add even an empty column store table, and you can just do this like as a temp table, I think. Put a column store index on a temp table that has no rows and just include that in the query, you can get this to work. I have not tried it in standard edition.
Okay,
So,
just for the other people to know, the idea that I'm trying this in that moment and in these last weeks, no conclusion yet. But the idea is to get a temp table with a row index with a where clause like ID equals 1 and ID equals 2. It's impossible in index, so it's empty. And you can do a left join in your query, and that's it. And it's supposed to happen. It's supposed to help. I don't know. No
yeah,
conclusions yet.
I have tried it in 2017 and it worked. However, I didn't try it on standard. So I'm going to make a note of that and to try it on a standard.
Oh, thanks.
Hi, Kathi, can I ask a question?
Sure.
Due to 2019, we are still in 2017. So for the batch mode on row store, we don't have to do anything and it will be, the performance will be there.
I'm not, could you repeat that, please?
So for the batch mode on row store, like for the aggregate, we don't need to do any, like it automatically when we go to 2019, it will be that feature
It will be there.
turned on.
Yes. So you have to make sure that your database is in that compatibility mode, 2019 compatibility modes. Because if you just upgrade and leave the compatibility mode in 17, you won't get it. But yeah, you should just get it and you've got to be on Enterprise Edition.
Yeah, thank you.
All right, I'm going to move on because I have very little time left. Memory grant feedback. So this is a situation where SQL Server estimates a certain amount of memory required and it's not correct. So two things could happen. One of two things. It either could spill to disk or it could actually just take more memory than it needs, which might not be a big deal, but in that case, you're taking resources that could be used for other queries. So in 2017, they introduced this with batch mode, in 2019 with row mode. And it does require Enterprise Edition. And I'm going to use wide world importers and set the compatibility level back. So if I look at the plan, I see this, it has a memory grant that was excessive. Okay, it decided it needed too much memory. And I think it was because there was a max, varchar max column in that. I increased the compatibility to 2019. I'm going to run this a few times. It doesn't always catch the first time you run it. And I can see that I still have the problem. But then eventually the problem is fixed. That warning goes away. If I look at the properties, I see this new section called Memory Grant Info. And you can see that the desired memory, the granted memory, yes, it's adjusting. So this is the status of that feature. This one is saved in cache, so you can have some issues where it the memory grant won't be right. So I'm going to run this, which calls it with two different values. And like here's a situation where it doesn't have enough memory. So you've got the spill to disk on the sort. And so we're going back and forth. Since it's going back and forth so much, let's take a look at what it says it's doing. There it is. Okay, so it's still adjusting here. At some point, let me go down pretty far. At some point, it should give up. So no feedback, it's disabled. So if you do have a lot of skew in your data, it will give up. It won't try to do that. But otherwise, if you like always have a pretty small number, small grant that you need, and the query thinks you need a large grant, that'll be fine, or vice versa. If you need it to go back and forth, isn't as helpful. So any questions about that one? Okay, let me just mention, there's one more I'm not going to cover, approximate count distinct. For data that's like streaming in that you have to get very quick counts on. And there are options to turn these on, turn the whole set off. You can change the database compatibility level. You can disable one particular property if you would like, and you can also disable it at the query with a query hint. The resources, if you go, just take a quick screenshot of that. If you go out there, there is code that shows how to do it. And let me talk for the remaining time I have. I just want to talk about 2022. There are several things that are being added in 2022. I am so excited about this one. Parameter sensitive plan optimization. This takes care of that situation where, let's say that with a small number of rows, it should be a seek with a key lookup. With a large number of rows, it should be a scan. Really, one way to solve that would be to modify the index. But if you don't want to do that, this particular feature will take care of it. It will let you have multiple plans against the same query. I've only seen 2 different plans demonstrated. But so instead of that one plan where that adaptive join, it will actually store multiple plans in the cache for one query. So I'm really, really excited about that. And there are demos about it. Bob Ward, some of the other Microsoft folks have demonstrated it. MacStop, that's a big problem for lots of people. And tweaking that, well, if you tweak it, you need to tweak it at the query level. Do you need to tweak it at the database level, at the server level? Well, starting with 2022, for a particular query, there will be feedback as far as degree of parallelism, where the optimizer will figure out what's the best setting, or not setting, but for that particular query, and adjust. Memory grant feedback, I guess that is misspelled. There we go. memory grant feedback, let's say that it's working great for your workload, but when you restart SQL Server, you know, that's gone. So they have modified the memory grant feedback so that it is saved in Query Store. So if you have Query Store enabled, that memory grant feedback information will be saved. It also added a new approximate feature called a function called approximate percentile. And that's similar to that count distinct, where you need to have something very, very fast, but it doesn't have to be 100% accurate. Also CE feedback. So if the cardinality estimate, there's different formulas depending on which version of SQL Server you have, which flags you've got and flags you got enabled, things like that. Well, in this case, what they're going to do is adjust based on the query performance. And I believe this one also works with Query Store, so that if a wrong formula is applied, it can adjust and apply another one and figure out what's the right one. There's another one called optimization replay. I have not, except for seeing it on somebody's slide, I haven't seen that one demonstrated, so I'm not quite sure what that one's about. So if you download the slides, which are also available in my GitHub, you'll see these links that you can get to. And here's a few more resources as well. So are there any additional questions?
Can I ask a question related to the table valued function?
Table valued function.
Yeah, how do we know when to use temp table versus table valued function?
Table valued. You mean table variable?
Yes.
You mean this one? Yes, because you wouldn't really table valued as function. So you mean table variable. In the past, I have not used table variables unless it was like a very small number of rows. That's what I've done in the past. If it was a lot of rows, like in the thousands, I would use a temp table. However, starting in 2019, table variables are looking much more, in 2019, table variables are looking much more attractive. So which version of SQL Server are you thinking about?
I'm currently on 2017.
17. So in that case, my advice is to use temp tables unless it's something really small.
What about the store procedure versus table valued variable functions?
Table valued functions?
Yeah.
Table valued functions are when you want a permanent object. So like in this case, this goes away once I'm done running my stored procedure, right? Table valued functions are a function that you define and you can see them, right? If I go here, I can see them here. So if they are multi-line table valued functions, I would say don't use them. If they are inline table valued functions, anytime you want, let's say you were thinking of using a view, but you want it to be parameterized. So a table valued, an inline table valued function, just do this. So an inline one statement. See, one select statement in the function. It's all that's in the function. It's nothing else. And so use like it was a parameterized. I cannot spell.
Actually, my question was related to the store procedure versus multi-statement table valued function.
Okay, but then you started asking me about. So did I answer your question here?
I'm not sure if you refer, when you create a table type, you have a variable as type. I'm not sure if this is what you refer to. I'm not sure, but I was just,
Great. So if I have a stored procedure and I'm going to need to store intermediary results, if it's just going to be, 10 or 20 rows, I use a table variable. If it's going to be thousands of rows, I'll use a temp table. So that's my advice. Others may have different advice.
That was fine, but my next question is related to when inside the store procedure. So we might use the table valued multi-statement functions and a store procedure. So which one would give us the performance?
Okay, so if I'm so if I want to talk about table valued, let's see, that's this one. If I want to, that's a different thing. We're comparing different things, which is why I started talking about table valued functions. Okay, it doesn't matter where I use them, whether it's in a stored procedure, an ad hoc query, inside another function, I could use them anywhere. Okay, so you're wanting to compare table valued functions to table variables. Is that what you're trying to compare?
Multi-statement table variable functions with store procedures.
So I would say don't use them.
Okay.
I mean, that's real. I mean, if you're on let's see, it's just so many it's depends. I mean, that's the answer people give, but I can't really, I'd have to see a particular situation. If you've got if you're running whatever version we need to run. Okay, so let's see what 2019. If you're running 2019, in some situations, SQL Server will take care of that multi-valued statement. Okay. Multi-valued. You can't get it out. Multi-line table valued function. Am I saying it right? In some situations, 2019 will take care of that. If you're passing in static values. So are you thinking of using cross supply?
No, I'm actually kind of confused related to when it's a good idea to use a store procedure, and because I do have two options. So inside the multi-statement table valued functions, I can write some logic and do the stuff, and also I can perform some operations in the store procedure. So I'm kind of curious which one should I use and when?
Yeah, you know, it's all going to depend, but my advice would be just don't do that. Don't use multi-valued table value, multi-line, isn't it? There's a
Just say it
abbreviation to it.
Multi-statement. Yeah,
Don't use those. Put that logic.
multi-statement.
Yeah, put that logic if you can just in the stored procedure. Don't put it in those functions, because for the most part, the performance is going to be bad. If it's an inline table valued function, that's great. That's going to do great. If it's the multi-valued table, multi-line table valued function, those are typically not going to perform well. There is a certain situation where Microsoft has fixed that in 2019, but I would, if I have the option, I would put the logic in the stored procedure instead.
Okay, thank you.
Okay. So anything else?
That was outstanding, Kathi.
Thanks.
Yep, and thank you so much for putting this together. Do you guys have any more questions? Feel free to let us know, or otherwise we can end on this session.
First, I'd like to thank Katie, and how these two questions that you wrote down during the presentation, how you go to like maybe share the answers? How can you do this?
The questions I wrote down. I'm not sure
Yes.
which questions.
No, these
Oh, those
questions.
questions on paper,
Yeah, yes,
Oh.
yes.
What I will do is I will research them. Can I send the answer to, well, what you can do
To the group.
to the group? I can do that. You can also email me.
Okay, great.